You want to find Taylor series for the function e to the negative 3x. Okay, about c is equal to 0, right? About the x value of 0. So we know that the common Taylor series for e to the x function is given as summation from 1 over k factorial times a to the kth power for all x values. Okay, so we're going to use this well-known Taylor series for the function e to the x to find the Taylor series for the function e to the negative 3x. And notice that this is also revolving about x is equal to 0. Okay, c is equal to 0 in this case as well, right? Because you don't see x minus c here, you just see x to the k, right? And not x minus c to the k, right? So it's about x is equal to 0, which is the situation as well. Okay, so let's try to transform this into that, right? So that's going to be e to the negative 3x means that we will simply copy down the 1 over k factorial and then replace the x with a negative 3x, right? So it's going to be negative 3x to the k, right? Because here e to the x is replaced with negative 3x, right? So we must do the same thing after the summation as part of the summation series. Okay, so negative 3x. So now we have to actually specify for negative infinity is less than negative 3x, right? Because we're replacing that x as well. Negative 3x is less than infinity. Dividing both sides by negative 3 reverses the sign, right? So it would be something like this. So it would be infinity is greater than x, right? Because we're dividing by negative 3, three sides of the inequality, by negative 3, like that, right? So that would give us infinity is greater than x is greater than negative infinity, which if you want to put in the standard way, if you just simply reverse these two guys, right, these two limits here, you will get the same as before. Negative infinity is less than x is less than infinity, right? So still for all x. Now the only thing that remains is to actually make this in a readable format, right? Something as simple as this. Because right now you're not going to read negative 3x to the k, right? You have to put the negative 3 outside. So let's see what we're going to do. So we're going to copy down 1 k factorial. Okay, and let's see. So we can put negative 3 to the k outside, right? So we can erase that 1, and we're basically going to put negative 3 to the k outside. We're going to factor it out. We're going to put it like this: negative 3 to the k outside, and then x to the k will remain. So we can put it in the middle. X, well, without the parentheses, we don't have to have parentheses. It's going to look like that, right? So x to the k. There we go. We just found the Taylor series for negative infinity is less than x is less than infinity. We just found the Taylor series about x is equal to 0 for the function e to the negative 3x. Okay, so now the radius, since we have the interval of convergence from negative infinity to infinity, it means that the radius of convergence is going to be infinity. Okay, because you're finding the midpoint, right? You're finding the midpoint between infinity and negative infinity. This is essentially 0, right? And from that midpoint, the radius is determined, right? From 0 to infinity, the radius is simply infinity, forwards or backwards, whichever you want. The radius is always going to be the positive, the absolute value. Okay, so there you go. And hopefully this video was helpful, and I'll see you in the next video. Thanks for watching.